Hi guys, before we even begin to get into all of our different physics problems that we're going to be solving this year, I need to teach some basics of problem solving and try to help you realize some skills that you need to use and some things you need to do every single time, no matter how simple or complex the problem is. First off, always draw a picture. It might seem unnecessary in many things, and as you get more practice, maybe you don't need to draw some other pictures or problems as you go, but one way or another, you need to be able to visualize what's happening, and a picture helps you do that. Make sure you label the picture very well too. So like here's an example of that. I've got a car and a tree, and you can kind of guess what's happening here. And then I put all my variables in my problem as well, or in my picture as well, to try to get an idea of what's going to happen. Because this picture, then allows me to take all of my variables and write it down, if you will, in a variable bank. Everything that I know and whatever I don't know and I might be looking for. So in this problem, I'm looking for the final velocity. The reason that a variable bank is so important is then it allows you to look directly at the variable bank, compare against against all the equations that you know to try to pick the right one, or the right ones, plural, if need be, the right equations. But before you even start picking the right equations, make sure to identify the physics of the problem. In other words, think big picture here. What type of problem might this be? What things is this using? Is this a deceleration problem? Is this a conservation of energy problem? Is this dealing with electricity and magnetism? What ideas are being used in this problem? And then knowing what variables you have, right, and what you're looking for, and knowing the general idea will allow you to pick the correct equation or equations that fit and can lead you into step 5, solving. Now, sometimes solving isn't this simple, where you just have an equation, you manipulate the equation around, you substitute in, and you solve, right? Sometimes you'll do that for one step, and then you'll have to take your answer and then plug it back into a different equation and continue to solve from there. Or maybe it's you solve for one object and then you solve for another object and compare, or instead of just substitution. So there's a lot of different possibilities that might require you go back through steps 3 and 4 for other parts of the problem. Another thought for you on this, you'll see me lots of times going back and forth whether I manipulate equations around first off using just letters and then plug in numbers at the end. That's the method that I prefer, simply because sometimes some of the variables will cancel out in more advanced problems, and you'll see that's the method that you'll end up seeing in college as well. But sometimes that makes students really nervous. They want to get numbers in immediately, and that's an okay thing too. So here in the beginning, you'll find that I am going to substitute numbers in the very beginning of all of our problems, and then solve using numbers and only one variable, the one we're looking for, as opposed to manipulating around just in variable format. Although we will be getting to that as we move along in this class. Lastly, check your answer. Don't just write down an answer and box it and let that be that. Please check your answer. Specifically, make sure it's reasonable. Cars do not go millions of meters per second, right? That is an unreasonable answer. It is not just a few hundred meters to the moon. Please make sure that what you have down makes sense. Another thing to do is to make sure you have correct units and significant figures. There was 2 sig figs provided in my problem, and so I have 2 sig figs in my answer. I made sure to round it appropriately. Another way to check your answer, and we'll talk about this a little bit later, is you can actually use the units through the equations to make sure that you're coming out with an answer that works. So these are just general steps you need to follow every single time. Draw a picture, write down everything you know and what you're looking for, think about the physics, pick equations, start solving. It might require a few extra steps, and then double check and never, ever, ever forget units and sig figs.